Our first equation here is f of 5x. Okay, so the first thing I want to do is identify whether it is vertical or horizontal. Then we'll identify the factor, and then use that factor to decide whether it's shrink or stretch. So for the equation, f of 5x, is this vertical or horizontal? It's horizontal. Why? Because it's inside the function. So we're going to circle the h. And when it's inside the function, what is the factor? Is it 5? It's the reciprocal, 1/5. So my factor is 1/5. And when the factor is less than 1, does that make it a shrink or a stretch? It makes it a shrink. So we have a vertical shrink factor of 1/5. Number 2, y is equal to the square root of 1/2 x. Is this vertical or horizontal? Horizontal, because again, it's underneath the radical, so it's inside the function. So we're looking at a horizontal. And if the number in the function is 1/2, what is the factor? 2. So all horizontal functions are reciprocal. And if it's a factor of 2, is it a shrink or a stretch? It's a stretch, right? When the factor is greater than 1, it's a stretch. When a is between 0 and 1, it's a shrink. Okay, number 3 is 3 times f of x. Is that vertical or horizontal? Vertical. Vertical. So the factor is the same number as what's in the equation, 3, which makes it a stretch. Okay, go ahead and try 4 and 5. Okay, so number 4 is 2/5 times f of x. Is that vertical or horizontal? Vertical, because it's outside the function. So the factor is 2/5, which makes it a shrink, because 2/5 is less than 1. And y equals 1/10 x plus 7. Vertical or horizontal? Vertical. Yeah, it's vertical because it's not in parentheses there, yeah. So we'll call that vertical, 1/10. So that's a shrink. Okay. All right, here's another. This is a, number 6 is y equals absolute value of 4/5 x plus 1. Vertical or horizontal? Horizontal, because it's inside the absolute value. So what is the factor? 5/4. The reciprocal, which is greater than or less than 1? Greater than 1, so that makes it a stretch. Okay, go ahead and give 7, 8, and 9 a try. Okay, let's look at number 7. Y equals 2 square root of x. Vertical or horizontal? Vertical, because it's out front, right? Yeah. So the factor is 2, and that makes it a stretch. Number 8, y equals 5/3 x squared. Vertical. Factor is 5/3, which is greater than 1, right? Stretch. Don't be fooled by the fraction, right? You have to ask yourself, is this fraction greater than 1? Right? If the numerator is bigger than the denominator, then it's greater than 1. How are 8 and 9 different? The 5/3 is on the inside now, right? And the square is on the outside of the parentheses, so that makes it vertical or horizontal? Horizontal. So my factor is 3/5, and that makes it a shrink. Okay. You might want to highlight some important information on this table we gave you. Note that the first column is vertical transformations, and that means they're outside the function. Your vertical transformations are outside the function. Your horizontal transformations are inside the function. And it could be any one of these parent functions at this point. We've looked at square root, quadratic, absolute value, linear, and constant functions. The constant is just that horizontal line. Translations always happen because of adding and subtracting. That moves it up or down if it's on the outside, or it moves it left, right. On the inside, remember that it's opposite of what you see in the function. So if it's x minus h, it actually moves right. And x plus h moves it left. Your shrinks and stretches multiply by a factor of a. A is actually in the function when it's a vertical shrink and stretch, but it's not written in the function when it's a horizontal shrink and stretch. A is actually the reciprocal, 1 over b, of the number that's in the function. Okay? And notice that both of them say if a is greater than 1, it's a stretch factor of a. If a is between 0 and 1, it's a shrink factor of a. And then lastly, a negative makes it reflect, right? So reflections come from negatives. Negative on the outside is a reflection in the x-axis. The entire equation gets multiplied by the negative, including the y value or the y-intercept, the y value of the vertex. And the reflection on the y-axis happens inside the function, and that is actually only multiplies the x by a negative. Okay, doesn't affect the other numbers. And then we just give you a little summary of the domain and range of the different functions. Okay, this is only the parent function. If you translate the absolute value up or down, if you reflect it on the x-axis, your range changes, right? Same with these two functions, the quadratic and the square root. Linear functions will always be all real numbers for both. Okay, so we're going to write a function g that represents this indicated transformation. This is the first time we are giving you the description, and you have to write the function notation and then the new equation. Every time before, we've given you the function notation, and you have to write the description and the new equation. So we're working a little bit backwards. The end result is still the final equation. So in our first example, we're taking f of x equals the absolute value of 1/4 x. And we're going to translate that 8 units to the left, followed by a vertical translation by a factor of 2. Anybody